A photon is born deep inside the sun, in a region so dense and energetic that matter exists in a state unlike anything we experience on Earth, where atomic nuclei collide violently and energy is constantly being transformed into light. From our point of view, what follows is a long and measurable journey, because once that photon finally escapes the sun's surface, it must still cross nearly 150 million kilometers of empty space before it can reach Earth, a voyage that takes a little more than 8 minutes according to every clock we know how to build. During those 8 minutes, planets continue to orbit, Earth keeps rotating, people move, breathe, and think, and history advances ever so slightly forward. Time, for us, flows normally, just as it always does. But for the photon itself, something profoundly strange happens. From the photon's perspective, there is no 8-minute journey, no crossing of space, no sense of movement unfolding over time. The moment it is created inside the sun and the moment it is absorbed by your eye are not separated by duration or distance. They are the same event. No waiting occurs, because waiting requires time to pass. No travel takes place, because distance collapses at the speed of light. The photon does not experience motion in the way we understand it, nor does it experience time in the way we live it. For light, the universe does not stretch out between here and there. It folds. This is not poetry, and it is not metaphor. It is a direct consequence of how reality behaves at its most fundamental level, and it forces us to confront an uncomfortable idea. The way we experience space and time is not universal. It is a feature of moving slowly through the universe, not a feature of the universe itself. So when we say that light takes 8 minutes to reach us from the sun, what we are really saying is something about ourselves, about the limits of human perception and the clocks we carry with us through spacetime. Light obeys a different logic, one that reveals a version of reality where distance and duration lose their meaning entirely. And tonight, by following that logic all the way to its limit, we are going to try to see the universe not as humans do, bound by time and separated by space, but as light does, where everything happens at once, and the cosmos becomes a single, connected moment. In everyday life, our understanding of the world is built on a simple and deeply ingrained assumption that distance and time are inseparable, that the farther something is from us, the longer it must take to reach it. This idea feels so natural that we rarely question it, because it works perfectly well for everything we encounter. A car takes longer to reach a distant city than a nearby one. An airplane needs hours to cross an ocean rather than minutes. And even a person walking across a room instinctively understands that more space means more time. Our intuition has been trained by a universe where speeds are slow, distances are modest, and the passage of time feels uniform and absolute. This way of thinking quietly assumes something else as well, something so familiar that it usually goes unnoticed, that speeds simply add together. If you are standing still and a car drives past you, you measure its speed in one way, but if you are moving alongside it, you measure a different speed, and neither measurement feels more correct than the other. Motion, in this picture, is always relative, and there is no speed that holds any special status. Faster simply means faster relative to something else, and in principle, there is no clear boundary between slow, fast, and faster still. Light, however, breaks this picture in a way that no other phenomenon does. No matter how fast you move, no matter how carefully you measure, and no matter which direction you travel, light always moves away from you at the same speed. If you chase a beam of light while traveling at thousands of kilometers per second, you do not see it slow down. If you move toward it, you do not see it speed up. Even if you imagine moving at a speed unimaginably close to light itself, the beam still escapes you at exactly the same rate. This behavior has no parallel in everyday experience and no explanation within common sense, because it violates the basic rule that velocities should combine. At first glance, this might seem like light is simply extraordinarily fast, so fast that our attempts to catch up to it are always futile. But that interpretation turns out to be misleading, because it treats light as if it were merely an object racing through space, when in fact it is doing something far stranger. Light is not special because it happens to move quickly. It is special because its speed is woven into the very framework of reality. The universe does not allow the speed of light to change, not because light is stubborn, but because space and time themselves rearrange to prevent that change from ever occurring. This is where intuition truly begins to fail. In order for light to move at the same speed for all observers, regardless of their motion, the universe must abandon the idea that time flows identically for everyone and that space remains rigid and unchanging. Instead, time stretches and compresses depending on how fast you move, and distances shrink or expand depending on your state of motion, all so that the speed of light can remain constant. In this sense, light is not adapting to the universe. The universe is adapting to light. What this reveals is that the speed of light is not simply a speed in the usual sense at all. It is a limit, a boundary that separates what is physically possible from what is not. Nothing with mass can be accelerated beyond it, not because engines are too weak or technology is insufficient, but because exceeding that limit would require breaking the structure of spacetime itself. Unlike the speed of sound, which depends on the medium carrying it and can be surpassed by moving through that medium, the speed of light does not belong to any substance or background. It belongs to spacetime. This single fact transforms our understanding of distance and time from absolute quantities into flexible, interconnected aspects of a deeper reality. It tells us that the universe has a built-in maximum rate at which cause and effect can propagate, a cosmic speed limit that applies equally to matter, energy, and information. Light does not merely travel within this limit. It defines it, acting as the benchmark against which all motion is measured and all events are connected. And once this idea is taken seriously, it becomes clear that light is not just another thing moving through the universe. It is the thread that stitches the universe together, the signal that reveals how space and time behave at their most fundamental level, and the reason why reality itself has the shape that it does. When we say that the speed of light is about 300,000 kilometers per second, it is tempting to treat that figure as just another impressive statistic, a record-setting velocity that happens to sit far beyond anything we can reach with machines or technology. But the deeper truth is that this number is not merely descriptive, it is prescriptive. It does not tell us how fast light happens to move, but how fast anything in the universe is allowed to move at all. It is not a convenience of physics, nor a limitation of engineering, but a rule that reality itself obeys at every scale, from subatomic particles to entire galaxies. This speed functions as a boundary, one that divides the possible from the impossible, and what makes it so extraordinary is that it applies universally, without exception. No object that possesses mass can ever reach this speed, no matter how much energy we pour into it, and no signal, no force, and no causal influence can ever exceed it. This is not because the universe resists us in some mechanical sense, as though pushing back against acceleration like friction or drag, but because the structure of space-time itself rearranges in response to motion in order to preserve this limit. As objects move faster and faster, space and time cease to behave the way our everyday experience tells us they should, stretching and compressing in precisely the way needed to prevent light speed from ever being surpassed. At low speeds, far removed from this cosmic boundary, these distortions are so small that they go completely unnoticed, allowing us to live comfortably within an illusion of absolute space and universal time. Seconds tick forward at the same rate for everyone, meters remain fixed in length, and motion feels straightforward and intuitive. But as speed increases and approaches the speed of light, these assumptions begin to fail, revealing that they were never fundamental truths, only approximations that work within a limited range of experience. Time begins to slow down for moving objects, not as a metaphor or a subjective feeling, but as a measurable physical effect, while distances in the direction of motion begin to contract, shortening the very space an object must cross. This behavior is not arbitrary, nor is it an odd side effect of motion, but a direct consequence of the universe enforcing its ultimate speed limit. The faster an object moves, the more energy is required to increase its speed further, and as it draws closer to the speed of light, the energy required grows without bound. No matter how powerful an engine might be, no matter how advanced a civilization becomes, the gap between any massive object and the speed of light can never be fully closed. The universe does not merely make it difficult to reach this speed, it makes it mathematically impossible. The key to understanding why this limit is so absolute lies in recognizing that the speed of light is not just the speed at which light travels, but the speed at which spacetime itself allows cause and effect to propagate. It defines the maximum rate at which information can move, the fastest possible connection between events, and the ultimate boundary of influence. Anything that happens in the universe can only affect other events within a region determined by this speed, forming a causal structure that keeps reality logically consistent. Without such a limit, cause and effect could become scrambled, allowing influences to arrive before their causes and undermining the very notion of sequence and predictability. Unlike the speed of sound, which depends on the properties of air and can be exceeded by moving through that medium, the speed of light is not tied to any substance or background. There is no medium to outrun, no reference frame in which light can be said to slow down or speed up. Its constancy is built directly into the geometry of space-time, meaning that attempts to exceed it are not merely futile, but conceptually meaningless. To ask what happens if something moves faster than light is like asking what lies north of the North Pole. The question itself assumes a framework that no longer applies. What makes this even more profound is that light itself does not approach this limit gradually, nor does it struggle to reach it. Photons, the particles of light, have no rest mass, and because of this, they exist permanently at this boundary, moving at the speed of light from the moment they are created. They do not accelerate up to this speed, and they do not experience it as a speed in the way we understand motion. For light, this limit is not something to be reached, but the only possible state of motion available. As a result, the speed of light occupies a unique position in the universe, acting not only as a limit but as a conversion factor between space and time themselves. It tells us how many units of space correspond to a unit of time at the most fundamental level, binding the two together into a single entity known as spacetime. In this framework, space and time are no longer independent backdrops against which events unfold, but intertwined dimensions whose relationship is governed by this constant. Change the speed of light, and the entire structure of reality would change with it, altering the nature of causality, motion, and even existence itself. The universe enforces this speed limit not through force or resistance, but through geometry, reshaping the very fabric in which all motion occurs. As objects move faster, time dilates and space contracts in exactly the way needed to keep the speed of light invariant, revealing that what we perceive as rigid and absolute is, in fact, flexible and relational. This flexibility is not a flaw in reality, but a feature that preserves consistency across all frames of reference, ensuring that the laws of physics remain the same for everyone, regardless of their motion. Seen in this light, the speed of light is not simply an impressive number measured by physicists, but the cornerstone of a universe that is self-consistent, interconnected, and deeply constrained in elegant ways. It defines the maximum speed of motion, the structure of causality, and the relationship between space and time, all at once. It is the silent rule that governs every interaction, every signal, and every event, shaping the universe not by brute force, but by the subtle and unavoidable logic of spacetime itself. And it is precisely because of this that the speed of light deserves to be called the speed limit of reality, not as a metaphor, but as a literal description of how the universe is built and why it behaves the way it does. When Einstein introduced the idea that motion affects time in 1905, he was not proposing a strange side effect of speed, but revealing a fundamental feature of reality that had always been there, hidden by the slowness of everyday life. Time, which we instinctively experience as steady and universal, does not flow at the same rate for everyone. Instead, it responds to motion, stretching and slowing in a precise and predictable way as speed increases. At the velocities we encounter in daily life, this effect is so small that it escapes notice entirely, allowing us to believe that seconds tick by identically for all observers, no matter how they move. But this apparent uniformity is only an approximation, one that breaks down as motion approaches the ultimate limit set by the speed of light. As an object moves faster, time for that object begins to slow relative to observers who remain at rest. This is not a psychological effect, nor a matter of perception, but a physical change in how time unfolds along that object's path through spacetime. Clocks carried by fast-moving objects tick more slowly, biological processes run at a reduced rate, and sequences of events stretch out compared to the same processes at rest. The faster the motion, the stronger this effect becomes, until time itself begins to lose its familiar meaning. As speed approaches the speed of light, time dilation grows extreme. Seconds lengthen, moments expand, and the flow of time nearly grinds to a halt. From the perspective of an outside observer, a clock moving at almost light speed would appear frozen, barely advancing at all. And at the speed of light itself, the equations of relativity lead to a striking conclusion: time stops completely. For anything that could move at that speed, there would be no passage of time between one event and the next. Cause and effect would collapse into a single instant. This is why the speed of light is not just a boundary for motion, but a boundary for time itself, marking the point where duration ceases to exist and the familiar flow of reality comes to an end. As speed increases, the universe does not respond by merely adjusting how long events take, but by reshaping space itself in a way that is just as radical and just as unavoidable. We tend to imagine space as a rigid, unchanging stage on which motion happens, a fixed backdrop of distances that remain the same regardless of who is moving or how fast. Yet relativity reveals that this intuition is incomplete. Space is not passive. It reacts to motion, and it does so in a very specific direction, the direction of travel. When an object begins to move faster and faster, the distances ahead of it begin to contract. Not symbolically, not visually, but physically. The space between the traveler and their destination becomes shorter when measured from the traveler's own frame of reference. A journey that once spanned millions of kilometers subtly compresses, as if the universe itself were folding inward along the path of motion. The faster the speed, the more pronounced this contraction becomes, steadily shrinking the gap between departure and arrival. This effect is not an illusion caused by perspective or measurement error. It is a real transformation of spatial geometry, one that ensures the speed of light remains constant for all observers. Time slows down, space squeezes together, and the universe reorganizes itself so that the fundamental limit imposed by light is never violated. Motion, at high speed, is no longer just movement through space. It is an active negotiation with the structure of spacetime itself. As velocity approaches the speed of light, this compression of space becomes extreme. Distances along the direction of motion shrink dramatically, collapsing more and more until they verge on disappearing altogether. From the traveler's point of view, the destination rushes closer not because they are accelerating harder, but because the space between them is being crushed. At the speed of light, the mathematics reaches its ultimate conclusion. The distance in front becomes zero. There is no space left to cross, no separation between start and finish. Departure and arrival coincide. The journey does not shorten, it vanishes. Space, like time, is pushed to its limit and ceases to exist along the direction of motion. A photon is unlike anything else in the universe, not because it is mysterious or exotic, but because it occupies a regime of reality that everything with mass can only approach, never reach. From the instant a photon comes into existence, it is already moving at the maximum speed allowed by the structure of spacetime. There is no gradual acceleration, no build-up, no transition phase. Its birth and its motion are the same act. The moment it exists, it is already traveling at the speed of light. Because of this, the usual rules that govern experience simply do not apply. Time, as we understand it, is defined by change, by sequences of moments unfolding one after another. But for something that moves at the speed of light, time has nowhere to unfold. Relativity tells us that as speed increases, time slows, and at the speed of light, this slowing becomes absolute. For the photon, there is no ticking clock, no duration between events. From its own perspective, if such a perspective can even be meaningfully defined, time does not pass at all. Space behaves just as strangely. Along the direction of motion, distances contract as speed increases, shrinking steadily as the velocity approaches light speed. For a photon, this contraction reaches its extreme limit. The space between where it is created and where it is absorbed collapses completely. There is no distance to traverse, no gap to cross. Emission and absorption are not separated by space. They are the same location in the photon's frame. As a result, the photon does not experience a journey. What we describe as billions of kilometers crossed or billions of years traveled is, for the photon, a single, indivisible event. The moment it is emitted is indistinguishable from the moment it is absorbed. Birth and death are not endpoints of a timeline, but the same point viewed from different frames of reference. In this sense, a photon is less like an object moving through the universe and more like a connection between events, a thread that links two moments in spacetime without ever existing in between. When we turn our attention beyond the scale of stars and planets and look outward to other galaxies, the strangeness of light becomes even more profound. Consider the Andromeda Galaxy, our nearest large galactic neighbor, suspended in the darkness of space more than 2 million light-years away. When you look at Andromeda on a clear night, the light entering your eyes began its journey long before human civilization existed, before the first cities, before agriculture, at a time when early human ancestors were just beginning to walk upright on Earth. From our perspective, this immense delay feels natural and unavoidable because distance and time seem inseparably linked. Farther away means older light, deeper into the past. Yet this intuitive picture exists only because of how we, as slow-moving beings with mass, experience the universe. For the photon itself, the story is radically different. The 2.5 million years that define the photon's journey for us simply do not exist in its own frame of reference. There is no long voyage through intergalactic space, no endurance across cosmic eras, no passage of time at all. The moment the photon is emitted from a star in Andromeda and the moment it is absorbed by a molecule in your eye are the same instant from the photon's perspective. What we call distance collapses. What we call duration disappears. The vast gulf between galaxies, which seems so absolute and overwhelming to us, is reduced to nothing. Andromeda and your eye, separated by millions of light-years in our measurements, occupy the same point in spacetime for the photon. Emission and absorption are not endpoints of a journey, but two faces of a single event. This realization reframes what it means to observe the universe. When you look at a distant galaxy, you are not merely seeing the past through a delayed signal. You are participating in a direct connection across spacetime, bridged instantaneously by light. The photon does not carry history forward through time. It stitches together two moments that, at a deeper level, were never separate at all. The most ancient light we can observe does not come from stars or galaxies, but from a time when none of those structures yet existed, from an era when the universe itself was still young, hot, and dense beyond anything we can easily imagine. This light, known as the cosmic microwave background, was released roughly 380,000 years after the Big Bang, at the moment when the universe cooled enough for matter and radiation to separate, allowing photons to finally move freely through space. From our perspective today, those photons have been traveling for about 13.8 billion years, crossing an ever-expanding cosmos, stretched and diluted as space itself grew larger and colder around them. We describe their journey as one of the longest imaginable, a voyage spanning nearly the entire history of the universe, witnessing the formation of the first atoms, the emergence of galaxies, the birth and death of countless stars, and the slow unfolding of cosmic structure. To us, this ancient light is a relic, a fossil record of the universe's infancy, carrying information from a time unimaginably distant in the past. It feels natural to think of these photons as having endured an almost eternal passage to reach us. Yet from the perspective of the photons themselves, this immense history does not exist. The billions of years that define cosmic evolution for us are compressed into nothing. There is no waiting, no aging, no long trek across expanding space. The moment these photons were released from the primordial plasma and the moment they were absorbed by our detectors today are the same instant in their frame of reference. The early universe and the present day coincide. This realization quietly reshapes our understanding of cosmic time. The oldest light in the universe does not bridge epochs by traveling through them. Instead, it directly connects two moments that appear separated only because of how we, as beings with mass, experience spacetime. In this deeper sense, the cosmic microwave background is not merely ancient radiation drifting toward us from the past. It is a direct, timeless connection between the birth of transparency in the universe and our present act of observation, revealing that even across the entire history of the cosmos, light experiences no time at all. The idea that photons are not travelers challenges one of the most deeply rooted intuitions we have about the universe. We instinctively imagine light as something that moves, something that departs from a source, crosses space, and eventually arrives at a destination after a long journey. This image feels unavoidable because it mirrors how everything else we know behaves. Objects move, signals propagate, messengers carry information from one place to another. Yet when we examine light through the lens of relativity, this comforting picture quietly dissolves. A photon does not experience itself as something that persists while moving through space. It does not carry a history, accumulate duration, or exist between departure and arrival. From its own frame of reference, there is no in-between at all. The event of being emitted and the event of being absorbed are not separated by time or distance. They are the same event, seen from different perspectives. What we interpret as a journey unfolding across space and time is, at a deeper level, a single space-time connection. In this sense, photons behave less like objects and more like relationships. They do not occupy space as they move through it. They define a link between 2 points in spacetime. The star that emits the photon and the eye or detector that absorbs it are joined directly, without any temporal gap from the photon's perspective. Light does not travel the universe the way a ship crosses an ocean. It stitches the universe together, binding events that appear distant only because of how we experience time and space. This reframing has profound consequences. It suggests that the universe is not a collection of isolated places connected by long, delayed exchanges, but a network of events already linked by light. Photons are not messengers struggling across cosmic distances. They are bridges that make those distances meaningful in the first place. What we call travel is simply how that connection looks to observers who move slowly through space-time, bound by mass and duration. If it were somehow possible to approach the speed of light while retaining a form of perception, the universe would begin to transform in ways that defy every visual instinct shaped by ordinary experience. The sky would no longer feel like a vast dome surrounding you, but like a dynamic structure being pulled, bent, and reshaped by your motion. As your speed increased, the stars ahead would appear to slide forward, crowding closer and closer to the direction of travel, as if the universe itself were funneling into a narrowing corridor. Objects that once filled the periphery of your vision would be dragged toward the center, concentrating into a shrinking region straight ahead. At the same time, light itself would change character. Photons coming toward you would be compressed by the relativistic Doppler effect, their wavelengths squeezed shorter and shorter as your speed rose. Starlight that once appeared warm and gentle would shift through blue, then into ultraviolet, then into X-rays and gamma rays, becoming increasingly energetic and hostile. The universe in front of you would blaze with intensity, not because there is more light there, but because motion forces that light into ever higher energies. Behind you, the opposite would occur. Light would be stretched, drained of energy, redshifted into invisibility. The stars behind would fade, first into deep red, then into infrared, and finally into complete darkness. As you approach the speed of light itself, this distortion would reach an extreme. Nearly all visible light would be crushed into a tiny, blinding point ahead, while the rest of the universe would vanish into blackness. Depth, distance, and structure would dissolve into a single luminous focus surrounded by nothing. But at the exact speed of light, even this strange vision would disappear. Seeing requires change, and change requires time. At light speed, time does not pass. Without time, perception cannot unfold. There would be no image, no experience, no moment of observation. Vision itself would cease, not because there is nothing to see, but because there is no time left in which seeing could occur. We are so accustomed to the flow of time that cause and effect feel inseparable, a sequence so natural that questioning it seems almost absurd. A stone falls because gravity pulls it. The glass shatters because the stone hits it. In our everyday world, causes precede effects in a linear, predictable order, and we measure time as a steady river carrying events forward. Yet, when we turn our attention to light, to the very quanta of photons racing across the cosmos at their ultimate speed, this intuitive order begins to dissolve. For a photon, the familiar sequence of before and after loses its meaning. Emission and absorption, what we conventionally see as separate events, merge into a single, inseparable occurrence. The photon is born and received in a single stroke, existing in a state where the distinction between beginning and end, between cause and effect, is irrelevant. From the perspective of light itself, the journey across space is instantaneous. There is no traveling through time, only the coincidence of emission and reception. What we perceive as a vast distance, an intricate chain of events, appears as a single moment from the photon's frame. This striking insight challenges the very notion of causality, revealing that it is not an absolute property of the universe, but a relationship dependent on perspective. For objects with mass, time moves forward, cause leads to effect, and our intuition holds. But at light speed, our familiar chronology collapses. What seems like a simple, linear flow of events in our world is, at the fundamental level, malleable, entwined with the geometry of spacetime itself. This realization does more than confound expectation. It illuminates the astonishing flexibility of the cosmos, showing that time, order, and causation are not universal laws, but emergent phenomena shaped by how we move through the universe. At the heart of the universe's most profound mysteries lies a seemingly simple truth. Nothing with mass can ever reach the speed of light. To understand why, we must first confront the nature of motion itself. When an object with mass accelerates, it requires energy, not just a little, but ever-increasing amounts as it moves faster. Push a car, push a bullet, push a spaceship, and the energy needed grows steadily. But as that object approaches the ultimate cosmic speed limit, the speed of light, this energy requirement begins to spiral toward infinity. No matter how advanced our technology or how powerful our engines, it would be impossible to provide the infinite energy needed to propel mass to this ultimate velocity. This is not a limitation of engineering. It is a structural rule embedded in the very fabric of spacetime, written into Einstein's equations of relativity and woven into the geometry of the cosmos itself. Photons, the particles of light, are entirely free from this constraint. They are massless, carrying energy and momentum, but no intrinsic weight to hold them back. They do not accelerate to light speed. They simply exist there, already moving at that absolute limit the moment they are born. This difference is profound, for it separates the world of mass from the world of light. While everything with mass is bound by inertia and finite energy, photons transcend these limits, gliding effortlessly across space, connecting distant stars and galaxies in a bridge of instantaneous interaction from their perspective. They define what is possible and impossible, what is bound and what is free, and in doing so, they shape the very rules that govern causality, motion, and the flow of time. Light is not merely fast. It is a manifestation of the universe's ultimate freedom, the only entity capable of existing in a state where motion, energy, and time converge in perfect unity. This is why only light, and other massless particles, can occupy this extraordinary realm, revealing the elegant and unforgiving boundaries that govern everything else. Photons, the particles of light, offer us a profound window into the true nature of reality, revealing insights that stretch far beyond what we can perceive with our senses. When we look at light, we are not merely seeing energy traveling from one point to another. We are glimpsing the fundamental architecture of the universe itself, space and time, which to us feel distinct and intuitive. The seconds ticking on a clock, the meters between objects, are not separate entities at all. Instead, they are intimately intertwined in a single, unified structure known as spacetime. This fabric of reality bends and twists, stretches and contracts, in ways that are imperceptible at everyday speeds but become unavoidable as velocities approach that of light. For a photon, the concept of distance collapses entirely. From the moment it is emitted, it traverses the cosmos without experiencing any time at all, and the vast stretches of space it crosses are, in its own frame of reference, essentially non-existent. What appears to us as years of travel across millions of light years is experienced by the photon as an instantaneous journey. This astonishing reality forces us to confront the fact that what we perceive as separate, linear, and continuous, the ticking of seconds, the measurement of meters, loses meaning at the fundamental limits of nature. Light teaches us that space and time are malleable, deeply connected, and relative, forming a stage on which all events of the universe unfold together rather than sequentially. In observing photons, we are observing more than particles. We are witnessing a revelation about the very structure of existence. The way light moves, the way it bridges distant points instantly from its perspective, shows that the universe operates under principles that defy everyday intuition. It is through light that the hidden unity of space and time becomes visible, reminding us that reality is far stranger, more elegant, and more interconnected than our daily experience might ever suggest. Every photon that reaches your eyes carries with it a story that began millions, sometimes billions, of years ago, traveling across the vast emptiness of space to arrive at the precise moment you perceive it. When you gaze at a distant star, you are not merely witnessing light. You are participating in a profound, tangible connection with a part of the cosmos that exists far beyond your immediate surroundings. This connection is not metaphorical, it is a physical reality. Each photon that strikes your retina is a particle of energy that has traversed unimaginable distances, interacting with countless gravitational fields, passing through regions of space that have long ceased to exist as they were when it started its journey. In that instant, your very being is tied to the star, linked across time and space in a way that defies our everyday understanding of distance and separation. Consider for a moment the scale of this connection. Light from the nearest stars takes years to reach us, from the most distant galaxies, millions or even billions of years. Every moment you look upward, your eyes become a bridge connecting you to events that occurred long before human history, to places where civilizations may never exist or have long vanished. In a sense, the photons entering your eyes are a messenger from the past, a physical echo of processes that occurred in distant corners of the universe. The atoms that make up your eyes, your neurons, and your consciousness are part of this dance, responding to these tiny bursts of energy that have been traveling relentlessly through the void. In this way, light is not just illumination. It is a universal thread weaving together all things. Through every photon, you are inextricably linked to the cosmos, participating in an unbroken chain of existence that stretches across time and space, connecting you in the most literal sense to the farthest reaches of the universe. The universe is not distant. It flows into you, through you, and becomes, in a sense, a part of you. For us, time seems to move in one inevitable direction, a constant river flowing from past to future, carrying with it every moment, every memory, every anticipation. We measure it with clocks, with calendars, with the cycles of the sun and the rhythm of our own hearts, and we experience it as something inescapable, something that binds us to the sequence of events that define our lives. Yet for light, for a photon traveling at the ultimate speed limit of the universe, this familiar flow does not exist. Time, as we understand it, does not apply. From the perspective of light itself, the journey from one end of the universe to the other, the travel across galaxies that takes millions or billions of years according to our clocks, happens in an instant. There is no waiting, no aging, no passage. The beginning and the end merge into a singular experience, a unity that defies our ordinary understanding of cause and effect. This simple yet profound fact reveals something extraordinary about the fabric of reality. The universe is not as fragmented as it appears. Distance, which to us seems vast and insurmountable, is a flexible concept when viewed through the lens of light. Time, which we treat as linear and rigid, becomes a malleable dimension, intimately linked with space itself. What feels separate, here and there, past and future, may be far less absolute than our senses and our instruments suggest. A photon leaving a distant star, traversing billions of light years, is simultaneously at its origin and at its destination. The separation we perceive is not fundamental. It is relative, contingent upon our own frame of reference, our own velocity through the cosmos. In this light, the universe begins to feel less like a collection of isolated islands and more like a vast, interconnected web where distance and time are threads that can stretch, bend, and fold. In observing the cosmos, we are witnessing not merely matter and energy, but a profound unity underlying all things, a reminder that separation may exist only in perception, while at its core, the universe flows as one. So the next time you see sunlight, or look up at the stars, remember this: for every photon reaching you, the entire universe collapses into a single moment. And in that moment, everything is connected.